Aluminum hydroxide is also called alumina trihydrate, despite the fact that it is neither an alumina nor a hydrate. Instead, it consists of three hydroxides that are ionically bonded to a central aluminum atom. Aluminum hydroxide is the most widely used flame retardant on the market because of its low cost and versatility in comparison to the other flame retardants, and as shown by this graph, it occupies 53% of the flame retardant market. Aluminum hydroxide is created using something called the Bayer process, in which bauxite ore, which has aluminum-containing materials such as gibbsite, is used to produce alumina or aluminum oxide. This is then dissolved in sodium hydroxide, creating AlOH3 or aluminum hydroxide. When enough heat is added to aluminum hydroxide, it decomposes into aluminum oxide and 3 molecules of water vapor. In order for combustion to take place, 3 things are needed: oxygen, heat, and fuel. If even one of these is missing, then combustion cannot take place. Aluminum hydroxide is able to suppress all 3 of these components that are needed to cause a fire. To suppress oxygen, the water vapor released by aluminum hydroxide reduces the concentration of oxygen in the air, which makes less available for combustion. Aluminum hydroxide is also about 35% bound water by mass, which when released covers the material and limits oxygen supply. To stop heat, the decomposition of aluminum hydroxide is an endothermic reaction, which can take in about 280 calories per gram of ATH. The water vapor molecules are also able to absorb some of the heat as well. One way that aluminum hydroxide is able to limit the available fuel is by leaving behind a char after it has been dehydrated in the form of aluminum oxide, or Al2O3. This char covers the material and blocks it from the heat source, and unlike the fuel, the char is not easily burned, and it helps to stop both oxygen and heat from reaching the fuel source. Aluminum hydroxide is used as a filler in polymers, which means that it's mixed into the polymer itself. This reduces the concentration of the polymer in the overall material, decreasing the available fuel and access for oxygen to interact.
Of the ingredients used to modify the properties of rubber and plastic products, the filler often plays a significant role. The term filler is misleading, implying a material intended primarily to occupy space and act as a cheap diluent of the more costly polymer. Most of the fillers used today offer some functional benefit that contributes to the processability or utility of the plastic compound. The general effects of mineral fillers on plastics are to increase stiffness, strength, opacity, weather resistance, water, solvent, abrasion, arc, and heat resistance, density, surface hardness, and thermal conductivity. Also to reduce elongation at break, creep, gloss, flammability, coefficient of thermal expansion, shrinkage, and cost.
As a filler for solids, aluminum hydroxide has more than just the flame retardant properties. It's also stain, water, and chemical resistant, and it can also increase the tensile strength of the solids, which allows them to hold significantly more weight than they would if they did not contain any aluminum hydroxide at all. Unlike other halogenated flame retardants, aluminum hydroxide is halogen-free. These halogenated flame retardants release toxic chemicals into the air when burned, which causes a hazard to health. It also acts as a smoke suppressant. Water molecules released in the dehydration of aluminum hydroxide are able to prevent the spread of smoke particles into the air. This makes it safer than others that produce hazardous smoke. These halogenated compounds interfere with flame reactions, which stop oxidation and produce toxic smoke. Although it is insoluble in water, aluminum hydroxide can be suspended in water, which makes it applicable in liquid products and coatings, such as paints, sealants, glues, as well as adhesives. Aluminum hydroxide can be used in furniture as well. Polyurethane foam is a type of foam that's used in furniture cushions. However, it's very flammable, so it begins to degrade at about 270 degrees Celsius. Aluminum hydroxide decomposes just before this, which allows it to act and remove the heat before the furniture begins to burn. It's also able to stop the flames without disturbing the actual structure of the polyurethane foam. One study found that using a polyelectrolyte multilayer, or PEM coating, in combination with aluminum trihydrate had the greatest flame resistance. These pictures show the results of that experiment. Image A shows the polyurethane foam without any flame retardants or coatings at all. Images B, C, and D show the polyurethane foam with various amounts of the polyelectrolyte multilayer coating being used. However, image E has the polyelectrolyte multilayer coating coupled with the alumina trihydrate flame retardant, which produced the least burned foam in the end result. This graph shows that the ATH-coated foam had a significantly lower heat release rate than the PEM-coated foam or the uncoated foam. Aside from just being able to be used in coatings and furniture, aluminum hydroxide also has its applications as a filler in things like epoxy resins, rubber, electrical wires and cables, fabrics, as well as other polyesters and polymers. In order to make aluminum hydroxide a better flame retardant in the future, research is being done to create nano-aluminum hydroxide. When put together with carbon nanotubes, these can significantly decrease heat release rates.